3D file formats.
There is currently an ever-expanding need for the use of 3D models, whether that's in 3D printing, video games, or augmented reality, which involves overlaying a 3D model onto a live video feed. Some of the most common tools for working with 3D models are Blender, which is free to use, AutoCAD, which is primarily used among engineers and architects, Cinema 4D, which is like a more professional version of Blender, and then Marvelous Designer, which is primarily concerned with fabrics and other clothing design. One of the issues with having this many tools to edit 3D models is that there are hundreds of proprietary file types that exist. To solve this problem, a number of neutral or open source formats were invented. One of these file types is .stl, which stands for stereolithography and is only concerned with the geometry of an object. Another option is a digital asset exchange file, which preserves the geometry, materials, and even animations of a file. Here we have a .stl file of an iPhone case that I recently 3D printed. Although an STL file may not be precise enough for, say, designing a jet engine, it is perfectly acceptable for anything a commercial 3D printer may require. In this encoding, the 3D model is covered with a mesh of tiny triangles. As the triangles get smaller, the approximation improves and the file size increases. To store more precise information, some 3D models take advantage of parametric surfaces, rather than tessellations. Materials are stored as a collection of images that each cover one piece of the tessellation. Current consumer tech, namely the infrared emitter present in the newest series of iPhones, makes it possible to create a 3D model from absolutely anything in a matter of seconds. As such, this is likely just the beginning for widespread technology aimed at storing 3D information as it continues to be more relevant to our everyday lives.